Hey guys, AP here, and today we are going to be continuing our Lightweight Java Game Library series. Now in this tutorial, we are going to be adding actual camera movement. So what we did in the last tutorial is we had some temporary camera movement. It works fine, I guess. I mean, you can't really, you see the one square at different angles, but that's it's okay. But what if we make it better? So what we can actually do is we can add our second vector into this, which is rotation. Now, I said in the last tutorial we can control rotation with our arrow keys. However, since I am a gamer, I actually know for PC gaming, you really control the camera rotation with the mouse. Like if you move up and down, you look up and down, left and right, you know, all that. So what I want to do is I want to control the rotation using the mouse, obviously. Let's get started. So the first thing we need to do is we need to actually get the rotation rotating, like get it rotated. So we can do that by using our mouse input. However, since our mouse input is where our mouse is and not like how much it's moved between frames, which is what we're actually looking for, we're gonna have to store a few more variables up here. So I'm just gonna make a new line. I'm just gonna say private double old mouse X, and then we're going to say old mouse Y, and we're going to initialize these to 0 because these actually do need to be initialized. And then we need new mouse X, or new mouse X, and new mouse Y, and these don't have to be initialized, but you can if you want to, just 0. So now that we have these, we can actually use them to get our rotation. So what we're looking for is the difference between the old and the new. So we can do that by subtracting the old mouse X with the new mouse, or the new mouse X by the old mouse X, and the new mouse Y by the old mouse Y. So the first thing we got to do is we actually got to get the new mouse Y. So we can do that by saying new mouse X is equal to input.get, and then should we get mouse X. And so with that, we can also do the same for the mouse Y. So get new mouse Y is equal to input.get mouse Y. So now that we have that, we can actually get the difference between them by subtracting the new mouse Y and the old mouse Y, or X and Y. So the first one we're going to get is we're just going to actually make these into floats right here, and we're going to get the X. And so we're going to cast this to float because we're messing with doubles, and we're going to say new mouse X minus, and then float. Actually, we can just say one float and that's it. Minus old mouse X. So what that will do is it will. Do I have to put? I have to put parentheses around these. Okay, there we go. So with this gets the difference between the previous frame and the new frame because we timed it, and it's 60 frames, or it's going to try for 60 frames. And we can do the same for Y by just replacing all the X's with Y's. And so after we do that, we want to set the old mouse X to the new mouse X, because now we're done with them, and now we need to set them equal to the new one, because that carries over to the next frame, and then the old mouse X for the next frame is the new mouse X for the current frame. So there we go. Now we have ourselves a way to get the distance between frames of our mouse. So say like that goes -10 pixels to the left, it will say -10 and 0, because roughly, it's not really, because I don't know the exact coordinates. So now that we have these, we can actually map this to our rotation. So similarly to how we do the vector up here, we can do the same thing but for rotation. And so after we get distances, we can just say rotation. So copy that and paste it for here. But instead of using move speed, we're actually going to rotate based off this distance, or difference. It's really difference, not distance. So how you would think we would have to do it is we would have to say dx dy, However, that is not the case because the DX and the DX is actually for looking up and down, because X origin is horizontal, and if you rotate it off the X origin, you look up and down. And so we actually have to flip these right here, and we also have to make them negative because going negative this way makes the rotation go the other way, because OpenGL rotation stuff. It's whatever. But if we actually run this, because we can actually run this, you're gonna see some cool stuff. As a matter of fact, it's just you try to like, if you barely move, it sort of works, but then if you like actually try to realistically move, it just goes crazy. And what's happening is that we are actually going way too fast, because 10 pixels is like 10 degrees, and then if you do that 60 times per second, that's just going to go way too fast. And so we're actually going to limit this with another variable called mouse sensitivity. And that's not how you spell it. Mouse sensitivity. Okay, there we go. And we're going to just set this to like the move speed. It's not really has to be that much different. And so what we can do is we can multiply the distances by this, and we can get a little controllable mouse sensitivity. So with that, we should be able to use our rotation correctly. Oh, that's a bit too slow. Let me speed that up a little bit. You can do whatever value you want. Just I'm trying to make it to my liking. Yeah, that should be pretty good. But if you see a problem, you see that I'm trying to actually rotate more to the left, but I can't because the mouse is too far to the left. Now, this is going to be an easy problem to fix. We just got to go into our window class. So, window, and then we're going to just create a couple new functions. So right here, we're going to have the ability to lock and unlock the mouse. And basically what that does is locking the mouse, it makes it go to the center of the screen, and you can move around. You still get all the different, like you still get all the mouse positions, except you can't leave the window, and it's actually stuck in the middle of the screen. And then when you unlock it, it's just like normal. So we're going to make a few variables, or a few functions, or methods. We're just going to say mouse state, and then we're just going to have a boolean, and that sets the lock. Okay, so in this method, we're actually going to set the input mode, which is just for the cursor. So we need to say glfw set input mode, the window you want to set for, which is our window, the mode, which is our cursor, so glfw.glf cursor, and then we need to set that to whether or not it's locked or unlocked. So if it's locked, if it's locked, we want to set it to glfw.glf. Oop, that's not glfw. glfw cursor disabled. And what that does is it basically locks it into the center of the window. And then if it isn't locked, then we're going to set it to normal. So we can copy that and say, instead of disabled, we can say normal. So with this mouse state method in here, we can actually call it in here. And we can say if clicked, go into it. So if input dot is button down, and then the left button, so glfw mouse button left, then we can just say window dot mouse state true. So what that does is it locks it to our window when we click on it, and then we can press escape to exit out of it if we're actually stuck in the window. So now if we actually click on it, as you can see, we're actually locked to the center, and we can move our mouse freely. And now if you see here, we can actually move our mouse according to the rotation, and we can also move. So that's pretty cool. You see me moving, the camera, you see me looking at the little square thing. But there is a little problem with this. You see, now that we're actually rotating our view, our movement is still locked to the 4 axes. So we're not actually able to move sideways like this. We're always going to move in the same couple directions. And so, like, if I move forward, I should be going towards the square, but I'm actually going to the right of it. And going backwards, I'm just going left and right. So this isn't actually the correct movement. So how we fix this is we have to do a bit of trigonometry. Now, before you go, because this is a math, these couple last tutorials are math oriented, I'm going to explain it to you real quick. Okay, so I'm here in Microsoft Paint to show you how we can actually do correct camera movement. So currently what we have is these 4 axes of movement. No matter what rotation we have, so say we're facing this direction, we're always going to be moving in these 4 directions, which is not what we want. We always wanted to set these 4 different axes. So say we have we're facing this way, we need to actually make this to where the 4 axes are oriented the correct way. So with that, we can actually do some trigonometry to fix this. So what I mean by that is, say we are facing this way right here. We are pointing this way, and we want to move forward this way. Well, the best thing we want is we want these axes to be oriented that way. So if this doesn't look correct, let me just try to erase this. So this is not the current one. We want this a movement. Now, excuse my poor erasing, but that's we have to do some trigonometry to get these axes correct. So I'm just going to undo all this. So to do that, we need to figure out the x's and the z's, because we're messing with 3 dimensions here. We have to use the x and z's because the y is going up and down. And so yeah, so here we need to figure out what the new how much do we need to move on the x and z to make this correct. Now, if you don't understand this, I'll link to another video, like always. But anyways, I'll try to explain it the best I can. So say we want to move, or our axis is right here. I'm just going to finish that real quick. So boom to there, and then to there. So as you can see, these are trying to be axes, and we are going to move accordingly. So with our rotation, which is here, we can actually get that rotation, which is right here, and we're going to call this theta. And theta is just a Greek letter that's usually meant to symbolize angles. So with theta, and we know how long our move speed is, so I'm just going to call this ms, and our move speed is a variable we set in our camera class. Move speed is to that. And so now that we know the theta, or the angle, and the move speed, we can get the x, which is this, and we can get the z, which is this. So with these 2 values, we can get the x and z, and we can then add it to our position to actually move accordingly. So like I said, we need to use some trigonometry such as sine, so sine, and then we also need to use cosine. So I'll explain the uses in here. So with this, we have theta, so we can say sine of theta. So get those in here, and cosine of theta as well. And since we know the hypotenuse, which is this long line right here, we know that this is equal to either, so this is sine, so this is equal to z of ms, or z over ms, and this is equal to x over ms. And so we need to find out what the z value is and the x value is. So using some multiplication, we can get the ms onto this side, so ms times sine, and then ms times cosine, and this is going to get our z and x values. Just finish that math equation up. So the final equation is x is equal to ms times cosine of theta, and z is equal to ms times sine of theta. So with that, we know how to get the x and z. But it's going to change for each situation. Say we're moving, so this is for moving to the right. So this is for when we press the D key. We're going to have to figure out what to press if we're using the A key. Now, it's actually very similar to this one, so I'll explain it for you. Oh, I also forgot to mention, since Z, this is going down, and since Z is negative going this way, so this over here is positive, we actually have to invert Z to make this correct. So X and negative Z. Okay, so the next thing we need to do is we need to find the other three. Now, we actually only need to find 2 of these values because if we know one of them, we could just do the opposite of that, and that will be for the other one. So we can do the opposite of D to find A. So A is basically negative X, Z, because X, positive X, negative Z, it will be negative X, positive Z for A. And so with that, we can do WS sort of the same way, but we actually have to find one of them. So I'm going to actually work out what W is going to be, and I'm going to take you along with me for that. So this right here is where Z is, this is where X is, and this is theta. Similarly to how we did the first one, we can say that sine of theta is equal to X, oh, and this is also move speed, I forgot to say, but that's move speed. We can say this is X over move speed. And then cosine is equal to Z over move speed. And so since Z is going in the positive, and they're all going positive, these are both positive. So X, Z. Now if we want to do the S, we need to do the opposite of it, like I said for this. So it would be negative X, negative Z. Just to simplify things, since we're using programming to do this, we can just say X and Z are equal to the, I'm just trying to move this, is equal to this. So if we get rid of that and put it here, we can say, put that right there, and we can say X is equal to that, and then we can say the negative and positive accordingly in our and when we are saying our translations. I can't really speak, jeez. So these are basically the only things we need to know, is the sine and cosine. So let's actually implement that. So of course, right off the bat, we need our variables I described in there. So float X is equal to math.sine. And since I really like degrees, I'm going to use math.2 radians, and then it's going to be the rotation of the y-axis, because the y-axis is the straight up and down, and that's how you look to side, as you can see right here, or right here, the dx. So if we do that, we have to cast this to a float, so float math.sine. And then we have to do the same thing for Z, but obviously for cosine. So Z is equal to cosine. And now with these, we also have to multiply it by move speed. So move speed, not move speed, move speed. Control C and Control V. So with that, with these values, we can actually implement this into our position in the vector and all that adding. So for A, which is going to the left, if I go back here, A is negative X, Z. So I think, wait. Okay, so a little discrepancy. As you can see, for these side values, the cosine and sine are actually switched, as you can see. So what we need to do is, instead of saying X for this, we need to say Z. And for A, it has to be negative. And then for here, it has to be X. And then for D, same thing, except, you know, opposite. So Z, negative X. And so that is our side values done. And so we can actually switch back to our normal standard with X and Z. So here we can say X, and then here we can say Z, and then here we can say negative X, and here we can say -Z. And then for that up and down, we don't need to change that because we're not moving in relation to any rotation for that. So if we now run this and we click on it and we rotate, if we go to the right, we go to the right, but if we turn to the right, we actually go right and left. We actually have camera movement correct. Oop. Just notice that. No, that's wrong. Well, W and S are actually in the wrong one, so I'm going to actually fix that. So W is actually the negative one and S is the positive one. Sorry for that error, but it shouldn't really affect much. I just fix it, and now you can actually move around accordingly. So now we can go around our flat 2D plane in 3D space, which looks pretty cool. We're finally able to get out of our camera restricted view of this flat plane, but it's just a flat plane. It's kind of boring. So we can actually spice it up by making this an actual 3D shape. Now in the GitHub, just go to the GitHub in the description, and you go to the tutorial number, which is 13. You should see a file that says cube.txt. Now I'm going to actually go fetch that. It's just right on my desktop, so get rid of all that. And we go in here and we say all this. So we're just going to copy that and we're going to replace that with this, or replace our current mesh, which is a little boring square, with our brand new cube. So if we run this, we should have some errors. That's not what I wanted. Oh, it's because of our vertex. So when I actually made this, the vertex color wasn't really used, so I got rid of it. So if we go to vertex, if wherever it is, so graphics, vertex, just get rid of all mentions of color. You can still have it if you're using solid colors, but I'm probably not going to use it, so we're going to get rid of it. We're actually going to implement it later on down the road when we actually have a working engine and we can do stuff. So all in here, get rid of all this color, and that should be it. So now if we run it and we press play and we look at this, as you can see, it's a bit bigger because it's actually 1 by 1, but you should also see that it's a cube as well. Whoa! We can go inside of it. We can see all the faces. That's pretty neat. We actually have a cube we can fly around in first-person space, which is really neat. So that is going to be it for this tutorial. I hope you guys enjoy it. If you want to see more of these tutorials, please make sure to leave a like and subscribe to the channel. And I'll see you guys later. Bye!